this is Kaizhang and this is my student number. So I'm going to walk you through my assignment 3, which covers two main parts: image convolution and neural networking. So let's start. First, in part A, working with imaging convolution use 2D kernels. Convolution helps us detect features like edges and lessing images. So I started by loading the image from the URL and converting it to the grayscale, and then applying different kernels to highlight specific patterns. So converting it to the grayscale. And applying it different kernels to highlight specific patterns like 45 degree lines here. So the results showed how kernels transform images to emphasize certain features. So I answered question about the edge detached kernel. So one kernel highlighted horizontal edges, while another focus on vertical ones. So kernels are like filters. They change how we see the image's structure. So for instance, like this, like this. So we can see actually it made edges pop out by calculating pixels. So when you calculating pixel value difference, it's like sharpening the image to see its skeleton. So this is part A. So let's see the part B. So part B was about building and training neural network using the CIFAR10 dataset, classify images into 10 categories like cars. So I started with a simple model. So here is create a model. So using the different layers. So here is a convolution 2D layers to extract features, and the maxi pulling layers to downsample and reduce complexity, and the flatten layer to prepare data for the dense layer, and also to dense layer for classification. So, and we can see after we running the code, we can see the training for 50 epics, the model hit around 65% validation accuracy, but showed the overfitting. Training accuracy kept rising to 80 around 90%, while validation stalled. So this means the model memorized training data instead of generalization. So to improve it, I added another cover 2D layers and a maxi pooling layer. So let's see the model here, and one cover 2D layers and one more maxi pooling 2D layers. So this cut deeper model reached, let's see the result, 70% validation accuracy, but still overfit. So keep going, and then and one more dropout layers to randomly ignore some neurons during training. So this can help prevent overfitting by forcing the network to learn more robust features, better generalization, and less gap between training and validation accuracy. Let's see the result here. So convolution kernels help extract the image features, and deeper networks can improve accuracy but risk overfitting. And techniques like dropouts regularize the model. Let's go back to the question. So let's see This question, did the network prevent since overfitting? Yeah. So the model showed overfitting around 20. So let's see the 20. So here. And the validation accuracy barely improved by 45. Training hit 88.29 percentage here, 55. So means the model was memorized instead of a general reason. So let's see how many layers. So this model has 4 layers. Actually, I already answered this question in previous video, and so this already is. So the original model had 4 layers and showed overfitting with a validation accuracy stuck around 65%, and adding an extra cover 2D and maxi pooling 2D layers increase the model's capacity, potentially improving features extraction and raising the validation accuracy to 68 to 70. However, this could lead to the slower training and more overfitting without regularization techniques like dropout. So dropout is like a training drill for neurons. It randomly turns off some of them during the training, so the network doesn't rely too much on specific ones. So this help it learn better and generalize to new data. When testing, all neurons are back on, but their outputs are adjusted to keep things balanced. This is my assignment 3.